So, I'm going to tell you about the light-dependent phase of photosynthesis. To start with, the photosystems. They're found on the thylakoids in chloroplasts, and they're made up of an antenna complex full of photosynthetic pigments which channel light photons, and a reaction center where light is directed to. Pairs of photosystems are involved in the light-dependent phase called photosystem 1 and photosystem 2. Now, firstly, a photon of light enters each of the two photosystems. This excites the photosynthetic pigments and is therefore known as photoexcitation. Next, the photon of light causes each photosystem to lose 2 electrons. This ionizes the photosystems and is known as photoionization. The electrons from each photosystem move to primary electron acceptors. The electrons from photosystem 2 have higher energy levels than photosystem 1, so the electrons can go to photosystem 1 and be used to reset the photosystem back the way it was to begin with. This is called photodeionization because the electrons mean photosystem 1 is no longer ionized. Because the electrons from photosystem 2 had more energy than was needed, this excess energy is used to produce small amounts of ATP. This process is called photophosphorylation. So far, photosystem 1 has been deionized and is reset back the way it was to begin with, but photosystem 2 is still ionized, and the remaining electrons can't be used to deionize it because they're needed to produce something that's used in the light-independent phase, which we'll come on to. So to deionize photosystem 2, a molecule of water is split using a process called photolysis into oxygen, hydrogen ions and electrons. The electrons are used to deionize photosystem 2. The oxygen is a waste product and is removed, and the hydrogen ions are used in the next and final step. So finally, the electrons from photosystem 1 are sent from the primary acceptor to a protein called ferredoxin. This is also an electron acceptor, and from here the electrons, along with the leftover hydrogen ions from photolysis, are used to create a substance called NADPH2, which is used in the light-independent stage of photosynthesis.